So in these types of problems, when we're doing the distributive property, we want to use the idea of the area of a rectangle. And how do we find the area of a rectangle? Base times height or length times width, right? So what I want to do is I want to make one of these the base, and I want to make the other one the height. So if you notice, if the 3 is the base and 4e plus 5 is the height, then to find the area of the rectangle, we're just going to take 3 times 4e plus 5, which is what we have here, right? So I want to put the 3 on one side, and I want to put the 4e plus 5 on the other side. Now I've drawn a rectangle model here for you. Where do you think the 3 is going to go? Should it go along this side up here, or should it go along this side over here? Why? So the 3 is going to go here because there's only one part to this side. And the 4e plus 5 is going to go up here because there's 2 parts up there. So we can use one part for the 4e and another part for the 5. So what we're going to do is we're going to take the first part right here, and we're going to put that right there. Put the 3 there. And then we're going to take the 4e plus 5, and we're going to put that on this side. Now, should I just write it like this, 4e plus 5? What should I do? Okay. Perfect. So to set it up, what we're going to do is we're going to have each term in the parentheses is going to get its own rectangle. So the 4e gets its own part right here, the 5 gets its own part right here. And now all we have to do to distribute is to find the area of those boxes, those rectangles. So how do we find the area of this rectangle right here? Yeah, we're going to do 4e times 3. Now the way I'm going to do this, just to keep things simple and to make things a little bit easier when we start factoring, I'm always going to put the thing on the left first and the thing on the top second. So I'm going to do 3 times 4e. It really doesn't matter which one goes first and which one goes second, because either way we're going to get the same answer, right? All right, so we're going to do 3 times 4e. Since we're using a distributive property here, we're going to be doing a lot of these. You don't have to write a equals every time anymore, okay? You don't have to write a equals to say that you're finding the area. We know that you're finding the area. So we're going to do 3 times 4e here, and we're going to do 3 times 5 here. You do need to show that work. Even though you don't have to write a equals, you still need to show that work. And what is 3 times 4e? 12e. And what is 3 times 5? So we get 12e here, we get 15 here. So if we were to distribute this, what would we end up with? I'm going to write it right up here. I'm going to write an equal sign to show that they're equal. That equals what? Somebody just said it. 12e plus 15. This is actually exactly the same thing we just did in the opener, right? The only difference here in our work is you don't have to write the a equals every time. You just need to show what you're multiplying together to get the area of each box. And then to write our answer, we're not really finding an area. We just want to know what 3 times 4e plus 5 is. So we're just going to write that next to it. So we're going to write 3 times 4e plus 5 equals 12e plus 15. And that's how we're going to write the answer. Does that make sense? All right, so let's do another one. All right, so on this one, it's a little bit different for a couple of reasons. First of all, the first factor here still has one term. So where's that 4f going to go? It's going to go on the left side over here. All right, and then the 3f minus 5, that's going to go on top, right? So where should I put the 3f? Yeah, I'm going to put it on top of the first one. What should go on top of this one? Should I put a 5? I'm going to put a negative 5. Now, what we're doing here is a geometry problem, right? We're finding the area of a rectangle. So that's a geometry problem. When we're finding the area of a rectangle in an actual geometry problem, you can't have a negative length. So a negative 5 here wouldn't make sense if this was a geometry problem. It's a good thing this isn't a geometry class, right? So even though it doesn't make sense to have a length of negative 5, we're still going to have the negative 5 there. And even though it doesn't actually make sense to have an area of -5, we're still going to put the negative on our area there. So we're using geometry to represent this problem, but that doesn't mean that everything has to be positive like it would be in a geometry class. All right, so let's go ahead and distribute here by finding the areas. How are we going to find the area of the first one? What two things are we going to multiply together? The 4f times 3f, and then for the second one right here, 4f times, I'm going to put this in parentheses so I don't think that it's subtraction, 4f times -5. And so now I just need to multiply these out. What's 4f times 3f? 12f squared. And what is 4f times -5? -20f. And so what's my answer going to be up here? Next to the problem, I'm going to write equals and then write my answer. What is that going to be? Say that again. 12f squared minus 20f. Why can't we combine these? Yeah, one of them's an f squared, the other one's just a regular old f. It's actually, so this is f to the second power, right? This is actually f to the first power. So this is f to the second, this is f to the first. They are not like terms, so we can't combine those. Any questions about those? Okay, example 3. We're going to use the distributive property again, but we're going to use the areas for the distributive property. And your picture looks different than mine. Can anybody tell me why my picture will not work and it needs to look like the one on your note sheet? Gabrielle? Looking at this side right here, there's only space for one term, right? But over here in our first factor, we have 2 terms. So this picture is not going to work. Since we have 2 terms here times 2 terms here, we should have a picture that has 2 boxes by 2 boxes. So I'm going to need a picture that looks more like this, more like the one that you have on your notes. All right, so where's the 2g going to go? Okay, where's the 1 going to go? All right, and then how about the 3g? And the 4? All right, so notice that in this problem here, this side right here, that side right there, that's 2g plus 1. And this side right here, that's 3g plus 4. So we keep each of the factors together on the same side. Would it be okay if I put the 3g and the 4 here, and the 2g and the 1 over here? We could do that and we would still get the same answer. But would it be okay if I switch the 1 with the 4? So put the 2g and the 4 here, the 3g and the 1 here. Okay, how about if I put the 2g and the 3g here, and the 1 and the 4 here? No. You have to make sure that the 2g and the 1 stay together on one of the sides. All right, so let's go ahead and do this. Keyshawn, can you tell me what the area of this first one's going to be? What do we multiply together to get the area? 2g times 3g. One way to do this that goes kind of fast, if I'm going to keep the 3g off for a second, if I just go down the side here, I know I'm going to multiply 2g for both of these. So I'm just going to put the 2g in both of them, and I'm going to put the 1 in both of these. And then I'm going to go up to the top, and I've got a 3g here, and I'll have a 3g here. So times 3g times 3g. And then what am I going to multiply by both of these? The 4, so 2g times 4, that looks like a minus. And 1 times 4. Jesse, can you help me multiply these out? What's 2g times 3g? Okay, good. What is 2g times 4? Alright, what is 1 times 3g? And 1 times 4? Alright, good. Now, my answer for this problem using the distributive property, is going to be all four of these areas added together. So am I going to write 6g squared plus 8g plus 3g plus 4? No, what can I do here? Yeah, the 3g and the 8g are like terms, so I can add those together. So which one should go first, though? 6g squared plus 11g, because that's the 3g plus 8g, plus 4. And that is your answer. Now, this is a little bit more work than using the distributive property the old way, but this, being able to do this is going to make the next kind of problem we're going to do with factoring a lot easier. So even though it's a little bit more work now, it's going to make things a lot easier for us later on. Okay, go ahead and do example 4. Try to do this one on your own. The first thing I'm going to do is I'm going to put the lengths of each of these parts here. So what should I put down the side here? Okay, so we're going to have an h there and a 7 here. I want to put a coefficient on this just so I know what number goes in front. So that h is the same thing as 1h. Okay, and then over here on top, I'm going to have a 2h here and a negative 5 here. Alright, so going across, I'm going to multiply 1h here and 1h here. And I'm going to multiply 7 here and 7 here. And then going down, I'm going to have a 2h and a 2h and a negative 5 and a negative 5. So what is 1h times 2h? 2h squared. Okay, what is 1h times negative 5? Negative 5h. Okay, what is 7 times 2h? Alright, and what is 7 times negative 5? Now, are you guys noticing a pattern on which ones we're going to be able to combine? It's almost always going to be these two, right? Have you noticed that? Alright, so when we write this, which one should go first? 2h squared. Then we have the 14h and the negative 5h. When we combine those, what do we get? Okay, it's a positive 9h, so we'll put plus 9h and then minus 35. Pretty easy, isn't it? Alright, next one. What's another way of writing this? 2j plus 7 squared means what? What does the square mean? It's 2 of them, right? So instead of writing 2j plus 7 squared, we could write this as 2j plus 7 times what? No. 2j plus 7. 2j plus 7 squared just means 2j plus 7 times 2j plus 7. And now it's the same kind of problem we just did, right? So the tricky part here is just knowing what that square means. Go ahead and do this one. So Aaron, the first thing we want to do is fill in the rectangle here. So what are we going to put down the side here?
2j.
Okay, thanks Aaron. And then how about across the top? 2j and 7. Okay, so then going across, what are we going to multiply in both of these boxes here to find the areas? Okay, so we got 2j and 2j there. And then in the bottom row? No. 7 and 7, right? Okay, then going down, we're going to have what? What are we multiplying by both of these? Yep, so we're going to have the times 2j from the top there and times 2j there. And then over here, we're going to have times 7 and times 7. All right, so Aaron, what is 2j times 2j? All right, what is 7 times 2j? Okay, what is 2j times 7? It's the same thing as we just did, right? Okay. And what is 7 times 7? All right, so then Aaron, to add them all together, which one's going to go first? All right, so we'll have the 4j squared first. Then when we combine these two here, what are we going to get? Plus 28j. And then plus the 49j. There's no j on that. You see a J there?
All
right. Okay. Last problem for the day. Let's